So, a very good morning to all of you. And greetings and congratulations for the National Space Day, the first National Space Day that India is celebrating today. And in this gathering, I welcome you all. And before we start the program, I would like to give you the details of the program. It will begin with the national anthem, and the next will be the felicitation of the guests, and that will be followed by the welcome address by Professor Suman Rai sir, the Dean School of Physical Sciences, and that will be followed by the introduction about the National Space Day, which I'll take care, and then the next will be the speech by our chief guest, Professor Prabhakar Rath sir, the Honorable Pro Vice Chancellor, Mizoram University. That will be followed by the video display, which is on the history of Indian space program, and the second video is on triumphant voyage of Chandrayaan. And that after that, we have the scientist Dr. Lalram Dina from the MIRSAC, Mizoram Remote Sensing Application Center, Aizawl. He will deliver invited talk. And the last part of the program, of course, will be the vote of thanks by my colleague Dr. Arvind Maurya, Assistant Professor, Department of Physics, Mizoram University. And after that, we have high tea. And after high tea, and I can say parallel to that, we have exhibition just outside, down there. So where our own students of third semester have come up with the model of Chandrayaan. And from MIRSAC side also, they have brought. So we will have the exhibition program like that. So to begin with the program, may I request to kindly play the national anthem and kindly rise up for the national anthem.
भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल गायन जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Please take your seat. So, moving to the next item, may I request Ms. Jyothanpui to please come and felicitate our chief guest, Professor Prabhakar Rath, the Honorable Pro Vice Chancellor, Mizoram University. Jyothanpui. Thank you, sir. Now, may I request Ms. Janet Saizampui Sailo to please come up and felicitate our scientist Dr. Lalram Dina from MIRSAC, Aizawl. Thank you, Ms. Jyothanpui and Janet. Now, moving to the next part of the program, I would like to request our Dean, Professor Suman Rai sir, the Dean School of Physical Sciences, to kindly deliver welcome address.
Good morning to everyone joining this today program. Today we gather to celebrate National Space Day, a significant occasion that honor our nation, a remarkable stride in space exploration. Today we mark the first National Space Day celebration organized by Department of Physics, School of Physical Sciences. As announced by the Prime Minister of India, has declared 23rd August of every year as a National Space Day to celebrate the successful landing of Chandrayaan-3 mission, which accomplished safe and soft landing on 23rd August 2023 at near South Pole on the moon surface marked as a Shiva Shakti. So it is my pleasure to give a warm welcome to all of you on behalf of the Department of Physics and School of Physical Sciences. We are very thankful to our Pro Vice Chancellor, Professor Rath, and now today is in charge Vice Chancellor of the university. He gave us his valuable time apart from his busy schedule, administrative and academic both. So he will grace us today on this occasion, and chairman of the program, Professor Tiwari, and we are thankful to the speaker, Dr. Lanram Dina, scientist, Mizoram Remote Sensing Application Center, Department of Science and Technology, Mizoram, who kindly agreed to give a lecture on the topic related to the space physics. And our special thanks to the faculty member from the other department, students, research scholars. Actually, in India, a space program was started in November 1969. Dr. Vikram Sarabhai was the first director of ISRO, Indian Space Research Center, and Chandrayaan-1 first mission was launched successfully on October 2008 from Sriharikota. The spacecraft orbited around at moon at height of 100 km from the lunar surface and provided chemical, mineralogical, and photogeologic mapping of moon. The most likely cause of end of this mission was due to the failure of power supply due to the overheating. Chandrayaan-2 was launched on 22nd July 2019. Chandrayaan-2 landed and crashed on the moon surface because of high velocity. The failure of the Chandrayaan-2, ISRO scientists and engineers continue persist and innovate, leading to remarkable success of Chandrayaan-3. Chandrayaan-3 successfully launched the Chandrayaan-3 was equipped with some equipments. Number one is laser-induced breakdown spectroscopy, LEAPS equipment. Second, alpha particle X-ray spectrometer, laser retroreflector array. Number 4 is instrument for lunar seismic activity. 5 is Chandra's surface thermo-physical experiment and radio anatomy of moon-bound hypersensitive ionosphere. So LEAPS is a special sophisticated instrument. High energy laser beam are used to focus on the surface of the moon soil. So actually it generates localized high temperature heat that create the plasma, and the light emitted from the plasma collected from some photomultiplier tube, and actually spectrometer analyzed the chemical that present. So atomic chemical actually present at several elements on the lunar surface, including aluminum, sulfur, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. So researchers still continue to analyze the data and still learning new things about moon. Chandrayaan and Mangalyaan made India proud. thanking you. A happy National Space Day.
Thank you, sir, for the welcome address as well as giving important points regarding the India's moon mission. So, moving to the next part of the program, I would like to give a brief introduction about the Indian space program. Of course, I'm not going to talk too much detail, or I'm not going to repeat what Professor Rai, the Dean, has already said. So, the ISRO, actually, the name ISRO came later. In 1962, National Committee on Space Research was constituted by Government of India, which was under Department of Space. And in 1969, the ISRO was established, Indian Space Research Organization. And at present, there are many centers of ISRO. So some of them I will just name. Vikram Sarabhai Space Center in Thiruvananthapuram, Kerala. Liquid Propulsion System Center, Bengaluru. ISRO Propulsion Center Complex at Mahendragiri. Satish Dhawan Space Center, Shar Sriharikota, where I think our moon, this Chandrayaan 3 launch also took place from there. ISRO Inertial Systems Unit, Tiruvananthapuram, Kerala. UR Rao Satellite Center, Bengaluru. Space Applications Center, Ahmedabad. This is also playing a very important and crucial role. Recently, one of the authors from this SAC, one paper has come up in the Nature, which is giving the information regarding how the moon was formed. So that is very important outcome that has come actually, which was the result of our rover, which did experiment and collected data. Those data has been analyzed and recently it is published in Nature. Then ISRO telemetry, tracking and command network. So we have two centers in Hassan, Karnataka and Bhopal, MP, which is the master control facility through which we control all the satellites that we are launching. And of course, this one or two centers in India itself is not sufficient to track the satellites. We have other centers in other countries also. They also cooperate and we receive data. But I'm talking about what is available within our country. Then what we do is we monitor and control all the geostationary and geosynchronous satellites. These two specific centers, the Hassan, Karnataka and Bhopal in MP, because there are variety of satellites. So those satellites which we are launching for the communication purpose in general, geosynchronous, that is 36,000 kilometers away from the Earth's surface. So these things, these kind of satellites are tracked and monitored by these two centers. And if you read the brief, you will find there are different series of satellites that we have launched in the past. INSAT, Indian National Satellites, GSAT, Kalpana, and IRNSS series. IRNSS means Indian Regional Navigation Satellite System. We are working on that. Then there is National Remote Sensing Center, Hyderabad, through which we are also having one project here in Mizoram University in Physics Department. They have provided us the lightning detector, and Mizoram University is one of the 25 centers across India where they are collecting data, and their objective is to study the pattern of lightning in India, because in the recent past there has been lots of deaths due to lightning, especially in the state of Bihar, and therefore the Ministry of Earth Sciences and the Indian Space Research Organization, they are working together and selecting 25 centers across India to collect the data and analyze the data to know the pattern of the lightning, so that it can come under the category of prediction. Now also we are predicting, but we try to improve the prediction. What I am saying is done by the Indian this Ministry of Earth Sciences, not we are doing. We are just one center of data collection. Then we have Human Space Flight Center, HSFC, of the ISRO. Then, as our Dean already spoke few things, so AstroSat mission, Mars Orbiter mission, then Chandrayaan 1, 2, 3, Chandrayaan 3 we launched from Sriharikota on 14th of July 2023, and it landed over the moon on 23rd of August, the today's date, last year. That means 2023. So that is the reason, one of the reason. Of course, the National Space Day is not for just one event, but we are trying to commemorate this day to know about the ISRO, its activities, its importance, and so on, all details. Then in the recent, one of the very important launching that ISRO has done is Aditya L1 mission. The Lagrangian point, it has been sent to Lagrangian point, and which is 15 lakh kilometers from the Earth's surface. And the purpose of this Aditya L1 mission is to study the sun's upper atmosphere, that what kind of things are there, because we all know the solar flare is one of the issues which affects the communication system over Earth. So with this kind of mission, we try to study the solar surface and what is rather, I should say, solar atmosphere, not just surface, that what is going on inside the sun and how it is going to affect in terms of the magnetic radiation and how it can affect our communication system. So this is one of the very important studies. India is not the first one to start this study, but NASA has already many missions in the past. But for India, we have done it for the first time, and our mission is working fine and giving the data. So this is one of the very important achievements. And of course, ISRO has developed several launch vehicles, the SLV, ASLV, PSLV, GSLV, SSLV. Recently, one satellite has been launched using the SSLV case. And Indian remote sensing satellite series, all of us might know, that is also playing a very crucial, very important role in the issues related to agriculture, related to yield forecasting, and so on. Because having the data, having the clear picture, very high resolution picture, the picture taken by Indian remote sensing satellites is at par with NASA. Even NASA is also using our information for their area, for their country. Many times we are supplying the data, and it is of the world level, means the quality is the best one, at par with NASA. So this is a very important type of satellite, which is not geostationary, which is not placed in the height of 36,000 kilometers, which is very few hundred kilometers above the Earth's surface, but it is very useful for the mapping. Suppose the government of India wants to know that how much area, how much hectare of the area in India there is paddy sowing. So calculating, sending people and collecting data, that means a very big headache, a very big work, time consuming, money consuming. But if we are able to take picture, clear cut picture, and we process the picture, then we are able to estimate. I'm not saying 100% correct, but we can get a very good estimate about the area of the paddy which has been sowed across India. And based on that, we can estimate the possible amount of production, that this much production may happen. So government can make plan that if production is less than our requirement, then they can proceed for the processing to buy things from outside. And if they have excess of the our yield, they can plan to export also. So these kind of things, this is one of the example. Not only that, about the water resources, about the other kind of resources, and that picture which are provided by remote sensing satellite, they can be processed and used for variety of applications, including agriculture, including for planning, and so on. Then now our ISRO is moving forward, as all of us know. Only this what we are doing last few decades, we are not stopping only there. Now much bigger plans are there. So we have one more facility, that is human rated launch vehicle we are developing. You might have seen sometimes there was a test that the vehicle is going and then it is landing back unmanned. There is no one there. So we are trying to test that also, because that will be required when we go for human mission to moon, or when we go for human mission to develop our own space station. Those things become very crucial. So all those facilities ISRO has developed, like what I was telling, is also called reusable launch vehicle, which it can land back to your port, that airstrip, and then you can reuse it, same thing. So that kind of things, the testing is going on, and the ISRO chairman already said that India is planning to have the manned mission over the moon by 2040. So for that also they are working very fast. So it is one of the future plans of the, as I said, Indian Space Station is one of the our very important plan, because ISS, which was the space station jointly developed by USA and USSR at that time, that is in a bad condition now, and the astronauts are trapped there, and they are not going to come in next 6 months. So the situation is like that. Of course, they will come, but what I'm trying to say that having a space station of our own will have that special advantage, and we do not depend on other country that please send my person to space. I want to join in that group. So we will have our own. On that, the ISRO is working hard. And another very significant thing which is happening and which will become reality very soon. I don't know then, because the timing is not given also in the literature from where I have taken. So I can't say the time. But in the near future, we will have our own GPS facility, our Indian GPS. We are using Google now, but in the our system, our ISRO and our government, they are working hard so that we have sufficient constellation of the satellites, with sufficient number of satellites. If we are able to launch, manage, and do everything properly, we will have our own GPS system. So that has been named by the Honorable Prime Minister as NAVIC, NAVIC, which is called Navigation with Indian Constellation. So this is going to be a very remarkable achievement from ISRO and from India, because if we are able to develop this, then not only the needs of our country will be fulfilled, but also we can provide our friendly countries up to 1,500 kilometers beyond the boundary of India, 1500 beyond the Indian territory. This service can be provided. So it is going to be not only to fulfill the needs of the domestic needs, but also our other countries also can get benefit, especially the neighboring countries. So this is in the process, and it is going to happen soon. Then there was a time when even whether Europe or US, people were started to question that why we should fund. The funding agencies used to question that why should we fund to the space research? Where is the application of this kind of research on the ground? Why the money of the country, the taxpayers' money, why we should pay you and you do research, and when it comes to the outcome and when it comes to the taxpayer, any benefit, you have nothing to say. There was a time. Now those days are gone. And the applications of the space technology and science is such immense, and it is on the ground. It is not only now in the paper or just theory. So I just name few because our chief guest sir has to go for another program. So I would not like to go to very detail in that. So if you talk about the applications, of course, as I said, the navigational things, we can take care of everything within our country, and as I said, 1,500 kilometers beyond the boundary of India. That is possible. Of course, disaster management. This is one case that suppose in a certain state, certain area, there is a flood, and you are not able to access that area. So if you request to the ISRO, they can provide latest picture of that area, and you will be able to know how much area of that is covered with water, or what is the possible access that I can do. Okay, or I can estimate that how much will be the damage. Okay, and you can make the plan accordingly. So disaster management is one of the thing. The tracking of the vehicle is one of the things which will happen in near future. That in traffic we can manage, we can control, and we can study and know the situation, where it is more, where it is less. So this kind of things will come up in future, which will be based on the satellite information. So it is coming to the outcome of the satellite research, or satellites, which we are investing a lot of money to launch a satellite, to man it, to maintain it. For that, the outcome is now in a quite large amount and large number of areas. It is coming up on the ground also. Then this integration with mobile phones, of course, we already know we are using mobile phones, and we use the GPS, which is developed by others. But when we have our Indian system, so for the one of the reason, I just sir, I can take this one please. So during the 29/11 Mumbai, the situation was like the people are inside, they are creating havoc, and our intelligence is totally nil about them. They are not able to know anything. They are not able to track or trap or hear what is going on, because those people were using satellite phones, and our system cannot track it, and therefore we were just helpless for many hours. I think you know that incident. So after that, and another incident was the Kargil war. In these two cases, it was felt by the government and the agencies that we should have our own system. Otherwise, it is very difficult, because after the government of India requested the US government to record their call. Otherwise, there was no record. So they are using their satellite. Those people in Mumbai, their call was recorded, and that became an evidence later on. And in the Kargil war, when the government of India requested the US government that please can you provide us the location of the people holed up in our territory, they said no, will not provide. So that was the situation when you have to fight in blind, completely blindly, no information, and without GPS information, without proper location. The kind of fight which Indian Army did was successful, but it was a lot of damage taken place because of this. So that since then the government was very serious that let us develop our own GPS, so that in the hour of the need or emergency, we have not to request to somebody who can say no. So this is the background, and based on which the ISRO is working. Then, as I said earlier, the mapping. In the mapping, not only the mapping of the water resources, but also we can have the remote sensing picture to know how much area of India is covered with forest, how much area is covered with faults, geological faults, or any other thing. If we want, we can get a very high quality picture, very high resolution picture in at present system what we have in the satellite. So these kind of things are few examples only, many more things to come. So the time has come where the space technology is going to the society. It is touching to everyone. Like in the recently in Assam, the farmers used to receive message from the satellites regarding the flood warning. So flood warning, of course, weather forecasting and cyclone forecasting. We have seen recently the cyclone which happened in Odisha, then Andhra, then Gujarat. Because of the very proper tracking, very accurate tracking, the loss of life, etc., was reduced drastically. So what I'm trying to say that this particular space technology or space science is not limited to space now. The outcome of the research is coming to the common man, to everyone on the earth. So on that basis, the future of this research is brighter, because now no agency can question like that, which they used to do earlier, that where is the outcome, where is the application in our society. So I think that makes an interesting thing, and those who are interested, you please visit the ISRO website to know much more about this. So with that, I complete about the introduction about this National Space Day. Thank you so much. So moving towards the main or the most important part of the program, may I request and invite our chief guest, Professor Prabhakar Raj, Honorable Pro Vice Chancellor, Mizoram University, to kindly deliver the speech, sir, and inaugurate this program.
Professor Suman Rai, Dean, School of Physical Sciences, Professor R.C. Tiwari, the coordinator and the organizer of this National Space Day program, Dr. Lalram Dena, the scientist, Government of Mizoram, Mizoram Remote Sensing Application Center, faculty members, heads, deans, and dear students. Well, this is the background that the Chandrayaan 3 was successfully, and it was a soft landing on 23rd August 2023. On this background, the Prime Minister of India, Sri Narendra Modi ji, announced that 23rd August of every year should be celebrated as National Space Day. And in 2024, this year, the theme of the National Space Day is touching lives while touching moon. If the scientists are going to be landed in the moon, if they are doing a lot of space research on moon, Mars, then what is its impact on the lives of the people? That is the theme they have identified in the year for this year. So, whatever happening in the space or whatever technology that the government of India or these various space organizations, just now they are referring to Vikram Sarabhai, Satish Dhawan, Indian Space Research Organizations, all are contributing for the development of space technology, and more research on space has a definite impact on human beings, human lives. So it may be scientific research, it may be technological innovations, it may be space research. There are many areas what the government says, your future is depending on, or the future of the nation. If the India needs to be a developed nation in the country, we have to focus on science, technology, engineering, and mathematics, STEM. And what is the purpose of, or what is the intention behind observing or celebrating National Space Day? The main aim and objective is how we can sensitize, promote awareness among the youth. They belong to schools, colleges, universities, so that they can develop their horizon of knowledge, ideas, and applications in the area of space science, and how the space science, space research is changing the human lives. What it was in 1960s, 70s, 80s, 90s, and in the 21st century, you are all witnessing, me, the technological developments that has happened. Gone are the days when we were depending upon internet with a telephone line. Now today we are talking about 4G and 5G. We need an effective and efficient communication system, whether it is related to weather prediction or any other technologies. The idea is how can we have very fast communication system. That is why in your mobile sitting here, you can say today 2:30 there is going to be rainfall, and it happens because of the technology that you are using. Therefore, space science, space research, any technological innovations has a great impact on the human beings, That is why the students, the youth, they should take more and more interest in the areas of space and technology, engineering, mathematics, so that your future is great. As I said, that you see, any disturbance, disorder happens in the ocean has an impact on plain area. Any disturbance in the ocean, sea, that's why you get heavy rainfall, storm, cyclone, super cyclone, so many things. Similarly, any things, any disturbance, any development that happens in the space has an impact on the human life on the earth. That is why it is in this context that the Prime Minister of India, with his great vision, has realized that if India needs to be a rich nation, a developed nation, that the today's youth, the younger generation, school, college, university, they should know that how much important it is science and technology, and more particularly the space technology, in which Chandrayaan 3 is a proud moment for us. That's why, how can you take more and more interest in these areas, so that if there is 24 hours day, it has its impact on human life. If it is 24 hours night, it has its impact on human life. Everything is linked to human life. So more research, effective research, innovations in these areas can make the human life very, I can say, the comfortable, pleasant, and the more and more development in these areas can bring lot of success to make the human life very comfortable. That is why this day, today, 23rd August, is being celebrated all over India as a National Space Day, and this is the reason behind to sensitize, to promote that how the Indian youth can create their interest in innovative research, creativity, innovative, and something they can contribute to the knowledge domain as an original theory, and that is why the country is going to be a great country, and all of us are contributing to the nation building. With these words, thank you very much to the Department of Physics and School of Physical Sciences. By organizing this program, our Vice Chancellor has taken a great interest, keen interest, by instructing the Department of Physics to organize this particular program. I am told that there is an exhibition outside the auditorium or in the ground floor. They have organized with the help of Mizoram government remote sensing organization, school, maybe Kendriya Vidyalaya school students, Department of Physics, they have organized an exhibition here. These are some of the activities that are being undertaken, celebrated all over India. Quiz competition, the exhibition, interactive discussion forums. There is a big function in the Bharat Mandap in the New Delhi, and so all parts of India today is being celebrated, so that the youth should know the importance of space, science, technology, and how they are going to be a great human resource and future of this particular country. With these words, thank you very much for giving an opportunity to speak some of my words in this occasion.
So thank you so much, sir, for giving the highlights and importance of the National Space Day, and also the importance given by the government level and other organizations. So since sir has to go for another program, so the formal vote of thanks will come up with my colleague Dr. Arvind later on. But right now, I would like to give a brief vote of thanks before sir leaves for the Pachunga University College program. So it's my pleasure and honor to thank you so much, sir, that for this program you have accepted our request and you have made available, and it has been possible on time, everything. And as sir has said already, our Honorable Vice Chancellor forwarded the information immediately and asked us to organize. We started working immediately along with my colleague Dr. Jodin Moya and the whole department. We had a faculty meeting and we decided all this program. And not only that, from the administration side, we got all the support, like financial support, as well as this auditorium and all other which was required for this program. Every support was given by them, and therefore we could organize this program. So I thank the administration, Honorable Vice Chancellor sir, the GAD, Engineering Cell. At the same time, special thanks to our Honorable Pro Vice Chancellor, Professor Prabhakar Rath sir, who immediately accepted our request and who make it on time and who gave brief but very important highlights and importance of this National Space Day, and also the future possibilities or future importance of this technology. And I would also like to thank our Dean, Professor Suman Rai sir, for being present in this program. Of course, he will be here also after the program also, but as a formal vote of thanks I want to give. And our scientist, Dr. Laramdina from Mizoram Remote Sensing Application Center, who accepted our request, and he will deliver invited talk as per the program after some time. Then, not only that, they supported us by bringing a model or something he had displayed that will be part of the exhibition. So thank you so much for supporting us. And moving to the next part of the program, which will be the video display.
India's foray into the space research started in the early 1960s, when the satellite applications were in the experimental stages worldwide. Dr. Vikram Sarabhai, a visionary behind India's space program, had strong conviction that the space technology could be effectively leveraged to tackle the problem of society and the country. The Indian Space Research Organization, ISRO, was founded in August 1969, and it was brought under Department of Space in September 1972. The prime objective of ISRO is the development of advanced space technology and application of space technology for societal, commercial, developmental, and strategic requirements of the country. While the 1970s were the period of conceptualization, the 1980s were the period of experimentation, which saw the demonstration of end-to-end capabilities through Aryabhatta, Bhaskara, Apple experimental satellites, and SLV and ASLV development launch vehicles. These initiatives laid a strong foundation for realization and deployment of operational Indian National Satellite System, INSAT, Indian Remote Sensing Satellite System, IRS, and for development and operationalization of Polar Satellite Launch Vehicle, PSLV. ISRO functions through various centers and units located across the country. ISRO has been making a steady progress in development and deployment of state-of-the-art infrastructure and systems. ISRO has successfully developed different class of launch vehicles for launching satellites of different payload capabilities. The PSLV, GSLV, LVM-3 and SSLV have shown their precise performances in placing satellites to various orbits of Earth, including LEO and GEO, further to the orbits of Moon and Mars. Recently, ISRO successfully conducted the demonstration of autonomous landing of reusable launch vehicle, RLV LEX. Further, ISRO is pursuing its endeavors to develop next-generation launch vehicle with higher payload capability while offloading the operational launch vehicles to industry. ISRO has launched fleet of communication satellites, including high-throughput satellites, into the geostationary orbit for meeting the requirements of television broadcasting, VSAT services, internet broadband, cellular backhauling, island connectivity, telemedicine, and tele-education applications. ISRO has launched several Earth observation satellites, namely Cartosat, RESAT, OceanSat, and also meteorological satellites for various applications in Earth and ocean resource monitoring, resource management, geospatial applications, and for weather and climate applications. The satellite data are regularly provided to various user ministries and other users. These satellites play a significant role in disaster management in the events of floods, forest fire, earthquake, landslide, tsunami, etc., saving valuable lives and assets. The satellite data have been consolidated, value added, and made available to various users through platforms like Bhuvan, Mosdak, and Vedas. Several government and private users are deriving the benefit out of these portals. NAVIC is the navigation system of India with a constellation of satellites operating from geostationary and geosynchronous orbits. NAVIC provides the position, navigation, and timing services for civilian and strategic applications. ISRO is continuously contributing to the capacity building in space infrastructure and human resources in the country through various sponsored R&D programs and outreach activities. ISRO actively collaborates with other space agencies and organizations worldwide. It not only partners with the spacefaring nations, but also works with space-aspiring nations in sharing expertise in space technology and applications. ISRO's contribution with space science missions, namely AstroSat, Aditya L1, and ExpoSat, is significant for the space research. Several national and international researchers and institutions have made use of the data from these satellites and brought out publications in renowned international journals. ISRO also undertook space exploration missions of Chandrayaan and Mars orbiter missions to study Moon and Mars, while developing the critical technologies. India has successfully landed its Vikram lander of Chandrayaan-3 closer to the southern polar region of the Moon. It has also deployed Pragyan rover to explore the lunar surface. These missions have not only expanded scientific knowledge but also have garnered international acclaim. Efforts are continued to scale new heights in this journey. Gaganyaan project of ISRO envisages demonstration of human spaceflight capability. The mission is to orbit Indian astronauts at 400 kilometers altitude for 1 to 3 days and bring them back to Earth safely. Various precursor missions are in progress for demonstrating the technology preparedness levels before carrying out the actual human spaceflight mission. These demonstrator missions include Integrated Airdrop Test, Pad Abort Test, and Test Vehicle Flights. Safety and reliability of all systems will be proven in unmanned missions before the manned mission. As announced by Honorable Prime Minister of India,
2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा जो हमें स्पेस के अज्ञात विस्तार को जानने में मदद करेगा।
ISRO is working on realizing an Indian space station, namely Bharatiya Antariksh Station, by 2035 and to land an Indian on moon by 2040. The journey of Indian space program continues to grow to serve the nation, the citizen and the humanity at large.
The moon, a well-known visible object in the night sky, has captivated the minds of both scientists and common people. The charming allure of the moon has enchanted people throughout history. Scientists believed the moon would reveal the mysteries of the solar system and our own planet Earth. This mysterious puzzle has fueled numerous expeditions to our celestial neighbor. India achieved a significant milestone in space exploration when Chandrayaan-1 was successfully launched on October 22, 2008. The spacecraft carried a total of 11 scientific instruments. It orbited around the moon at a height of 100 kilometers from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. With the suggestion of former President Dr. APJ Abdul Kalam, ISRO achieved a remarkable feat by creating the Moon Impact Probe, which became the first Indian object to touch the lunar surface. This accomplishment is a testament to India's innovative approach and dedication to space exploration. The presence of water, H2O, and hydroxyl, OH, on the lunar surface was a groundbreaking discovery of the Chandrayaan-1 mission and opened up new possibilities for lunar exploration. The follow-on mission, Chandrayaan-2, was successfully launched on July 22, 2019 by the ISRO's heavyweight LVM-3 M1 launch vehicle. The Chandrayaan-2 satellite was made up of orbiter, lander Vikram, and rover Pragyan. The orbiter is still healthy and continuing its observations about the lunar surface. The suite of orbiter payloads with unique capabilities is offering valuable insights into the lunar surface, providing a plethora of information to the scientific community and conducting a comprehensive analysis of the moon's topology. The Chandrayaan-2 mission paved the way for Chandrayaan-3's soft landing on the lunar surface. On July 14, 2023, ISRO's heavyweight launch vehicle LVM-3M4 successfully launched the highly anticipated lunar mission Chandrayaan-3. The Chandrayaan-3 integrated module is configured with a propulsion module and a lander module with the rover housed within the lander. The lander module of the Chandrayaan-3 has been enhanced to ensure greater durability and resilience, surpassing the capabilities of the Chandrayaan-2 module. It has been reinforced to independently adapt to a wider range of variables, enabling a safe and soft landing. Detailed tests have been carried out for the performance evaluation of the lander systems on Earth to ensure the capability of lander for autonomous, safe, and soft landing in all possible conditions. The propulsion module comprised a payload called spectropolarimetry of habitable planet Earth, SHAPE. This payload was designed to discover how smaller planets in reflected light would allow us to probe into a variety of exoplanets which would qualify for habitability. The lander module was equipped with 4 payloads, namely radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Brahma, was used to measure the near-surface plasma density and its changes with time. Chandra's surface thermophysical experiment, CHAST, carried out the measurement of thermal properties of lunar surface near polar region. Instrument for Lunar Seismic Activity, ILSA, measured the seismicity around the landing site and delineating the structure of the lunar crust and mantle. Laser Retroreflector Array, LRA, was a passive experiment to understand the dynamics of the Moon system. The rover module was equipped with two payloads: Laser-Induced Breakdown Spectroscope or LIBS, did qualitative and quantitative elemental analysis and derived the chemical composition and infer mineralogical composition to further our understanding of the lunar surface. Alpha Particle X-ray Spectrometer, APXS, determined the elemental composition of the lunar soil and rocks around the lunar landing site. The LVM-3 rocket successfully deployed the Chandrayaan-3 satellite into an elliptical parking orbit at a distance of 170 by 36,500 kilometers. Following the sequence of Earth burns or EBN, the spacecraft was precisely inserted into trans-lunar orbit. On August 5, 2023, Chandrayaan-3 successfully entered the lunar orbit at an intended distance of 164 kilometers by 18,074 kilometers. Then the spacecraft achieved a lunar orbit of 153 kilometers by 163 kilometers through a series of lunar burns. On August 17, 2023, the lander module was successfully detached from the propulsion module. After a series of maneuvers, the lander module was successfully brought into a 25-kilometer by 134-kilometer lunar orbit. Consequently, the lander module initiated the power descent phase to achieve a soft landing near the south pole of the lunar region. Then, the much-anticipated spacecraft landing on the lunar surface had begun. On August 23, 2023, the long-awaited Chandrayaan-3 spacecraft achieved a successful soft landing on the Moon. The entire country witnessed the event and cherished the triumphant occasion. The entire nation was filled with pride as they witnessed the relentless efforts of the Indian Space Research Organisation. The Honourable Prime Minister, Shri Narendra Modi, witnessed the triumphant event through virtual mode and applauded the valiant efforts of the ISRO scientists.
चंदा मामा बहुत दूर के हैं, चंदा मामा बहुत दूर के हैं, अब एक दिन वो भी आएगा जब बच्चे कहा करेंगे चंदा मामा बस एक टूर के हैं.
On August 24, 2023, rover ramped down from the lander and India embarked on a historic moonwalk. After coming back from South Africa and Greece, the Honourable Prime Minister promptly headed to the ISRO Telemetry Tracking and Command Network, ISTRAC, in Bengaluru on August 26th. During his visit, he expressed his admiration and delivered a historic speech about the achievements of ISRO scientists and the lunar mission Chandrayaan-3. He also saluted the pivotal contribution made by the women scientists of ISRO, the Nari Shakti, in the successful accomplishment of India's lunar landing mission. By achieving this historic feat, he has given it the names
चंद्रयान-2 के पद चिन्ह जहां है, वो स्थान आज से तिरंगा पॉइंट कहलाएगा और जहां पर चंद्रयान-3 का मून लैंडर पहुंचा है, वो स्थान आज से शिव शक्ति पॉइंट कहलाएगा।
To commemorate the grand success of Chandrayaan 3, the government of India announced
23 अगस्त को जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
to honor India's amazing space exploration journey. MyGov, in collaboration with ISRO, conducted the Chandrayaan 3 Maha Quiz, in which millions of students participated. The remarkable achievement of Chandrayaan 3 highlighted India's impressive technological advancements, scientific expertise, and unwavering dedication to the exploration of outer space. India's success will further strengthen its position in the global space community. The success of this mission will ignite a sense of pride and inspiration in future generations.
Thank you so much, Dr. Jodin Moya, from my colleague in the Department of Physics, for arranging this nice presentation. Now, moving to the next part of the program, may I request and invite Dr. Lalaram Dina, the scientist from Mizoram Remote Sensing Application Center, Department of Science and Technology, Government of Mizoram, to make his presentation as invited speaker. Please.
Good morning, everyone. I feel very honored to share this occasion of National Space Day along with these respected professors, faculties, and students. The theme for my talk today will be space technology for remote sensing and GIS. But before coming to my theme, I would like talk about the brief history of Indian space program. Before ISRO, India Space Research Organization was formed. It was named in COSPAR. ISRO was formed after Dr. Vikram Sarabhai came back to an independent India in 1947, and ISRO was formed in 1969 along with several prominent scientists, which are Dr. APJ Abdul Kalam, Dr. Satish, the one from which we get the Satish, the one Space Center in Sri Harikota, and Dr. K.S. Sivan and Dr. Iwa Rao. And from these founding fathers, we have realized the launch of many important space missions. Thamba Equatorial rocket was the first rocket launched by India, and after that, it was preceded by Aryabhata. And from that, we get these several launches. Which we have now come to in 2023, the launch of Chandrayaan 3. So let me get on with my presentation, space technology for remote sensing and GIS. I believe that remote sensing is one of the branches of science which benefited most from this advancement in satellite technology, because since the advancement of satellite technology, the advancement in remote sensing has also skyrocketed. Earlier, before 1960s, remote sensing was mainly done using balloon photography, pigeon cameras, kite photography, and aircraft. During this era, they mainly fixed a camera on these flying objects, and camera photos were taken. And this was not very reliable and short term. With the advance of this satellite after the 1960s, remote sensing has gone on to a new platform, which is known as a satellite-based remote sensing. And here we can see the several elements involved in remote sensing. First, we need an energy source or illumination, which can be either artificial or natural. We will come on to that a little bit later. And then there is a second one, is the radiation and the atmosphere. And the third one is the interaction with the objects, recording of energy by the sensor, transmission, reception, and processing. interpretation and analysis, which is done through a software, and this application in various branches of science. And here we can see the different type of orbit, which are geosynchronous and sun-synchronous satellite. The sun-synchronous satellites are usually low orbit satellites, and they revolve around the Earth from polar to polar. And the geosynchronous orbits around the Earth from equator to equator, and they are usually at an altitude of around 36,000 kilometers. The Earth observation mission are usually done in this geosynchronous orbit. And here we can see the remote sensing technologies are used to record data and monitor changes in the atmosphere by acquiring information through radiometric measurements from this satellite. Atmospheric and ocean temperature, greenhouse gases, changes in land sea ice elevation, and changes in land sea vegetative cover are all covered by this satellite. And this radiometric measurement are recorded by a sensor that detects interaction between electromagnetic energy and the atmospheric oceans and Earth. These sensors are placed aboard the Earth satellites, which orbit our planet in Earth observation missions. Here you can see the data acquired by Landsat satellite. On the left side, you can see the normal photograph captured by the satellite, and on the right side, you can see the image captured by the infrared, near infrared range. Water is darker in the near infrared image, which is in the right side, and appears darker. So it is we are able to differentiate the water more here. So this is just one of the few examples of the different bands of images which we utilize in the remote sensing application. And here we can see some of the most important satellite in remote sensing branches. The first satellite you see here is the Cartosat series, which includes Cartosat 1, Cartosat 2S, and Cartosat 3S. Cartosat is the first Indian remote sensing which have a very high resolution data, with having a optical resolution, and true panchromatic resolution, which are able to obtain images simultaneously from the back side and from the front side, and they are able to produce a stereo pair image from which we can derive this 3D map like this digital elevation map, which are useful for delineating the elevation data. And the middle one is the Kalpana 1. The Kalpana 1 is the first dedicated meteorological satellite, and it carries a very high resolution radiometer payload, which is used to simultaneously obtain atmospheric cloud cover, water vapor, and temperature data. And next is the Indian National Satellite, INSAT 3DS. It is the first geostationary orbit India satellite at 36,000 kilometers with atmospheric sounding capability, providing valuable information over India and surrounding oceanic region. And below we have the OceanSat series, which are OceanSat 1 and OceanSat 2, which in OceanSat marks the beginning of space-based observation for oceanographic application, and the OceanSat 2 carries OCM2, which is Ocean Color Monitor 2, and Q-band scatterometer, which mark India foray into space-based active remote sensing. And a compact, lightweight, dual-frequency SAR was flown on board Chandrayaan-2 with full polarimetric capability, and the data received from the remote sensing satellite are utilized for cartography, which is map drawing, oceanography, land use, and climate studies. And here is the NAVIC system, which is navigate with Indian constellation. It constitutes of 7 IRNS, which is Indian Regional Satellite System. 3 satellites are in geostationary orbits at around 36,000 kilometers, and 4 are geosynchronous, which are in the geosynchronous orbit, and the cost is around 1,420 crores. It covers India and up to 1,500 kilometers beyond its borders, and there are plans to expand this to 3,000 kilometers beyond Indian borders. These IRNSs provide standard positioning service, and they are now coming to opening to all users, and the accuracy is better than 20 meters. And right now, this is the platform in which remote sensing are based. Here are the different base. One is the low in remote sensing, one is the low altitude base, and one is the high altitude base, and one is the satellite data base. The low altitude data is based on mainly manual photography, and the second is the high altitude data, which is based mainly on drone or aerial photography, and the third is the satellite data, which is based on the satellite. And here you can see on the satellite you have different bands, which may be multispectral or hyperspectral. And we will also go into detail about the various resolution present in the remote sensing, which are mainly spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. Spatial resolution is a measurement of art object in a pixel, which is in an image. So the if larger area are represented in a pixel, the more unclear it will be, and if a smaller area is represented in a pixel, the more clear it will be. This is the exact opposite of what is in your mobile camera. In your mobile camera, suppose your mobile camera has 40 megapixel resolution, the image you see will be clearer. But in this satellite terms, if meta resolution is less, the imagery will be more clearer. For example, you can see here 0.5 to 0.5 meter produce a better resolution here than 20 to 20 meter resolution. And the spectral resolution is the ability to observe spectral features and then into their separate components, which means that the different themes such as land, sea, and water will be able to differentiate more. And temporal resolution is the frequency at which images are recorded, captured at a specific place on Earth. The more frequently it captures, the better or finer the temporal resolution will be. For example, a sensor that captures an image of an agricultural land twice a day has better temporal resolution than a sensor that captures the same image once a week. And here you can see the radiometric resolution, which depends on the sensitivity of the sensor to the magnitude of the received electromagnetic energy, which means that this measured in terms of bits. So 8-bit resolution will have less detail than compared to a 16-bit, and a 16-bit will have less resolution than, and will be less detailed than 32 bits, and so on. And coming to the remote sensing cycle, here we have the remote sensing. The remote sensing includes the mission plan and the choice of sensor, the reception, recording, and processing of the data, the analysis of the resultant data. And coming to remote sensing, there are two types of remote sensing. One is active remote sensing, and the second one is passive remote sensing. Active remote sensing, in active remote sensing, the object uses its own source of light, whether it is daytime or nighttime. It will also be able to capture the data using electromagnetic emission. And passive remote sensing uses naturally occurring energy like sunlight to illuminate the target and record the reflected resolution. In here, the passive sensor includes satellites such as Landsat, Aster, QuickBot, Iconos, and the active sensor includes LiDAR and radar. And here are the advantages and disadvantages of satellite images. The advantage of satellite images is it covers a large area, it is cost-effective, time-efficient, multi-sensor, multi-temporal, multispectral, and it overcomes inaccessibility, and the data is usually extracted or prepared for GIS. And the disadvantage is satellite data usually needs ground verification. That is, after we acquire the image, we have to go to the ground to verify whether it is really there, and it doesn't offer specific details. If you want to go to specific details, we have to use a drone imagery again. So it is not the best tool for small areas, and you need an expert system to extract data. And here is the application domain of remote sensing. Here, remote sensing can be applied to physical science, geography, geology, biological science, cartography, and social science. And here we'll go into the detail. Yeah, remote sensing is also used in urbanization and transportation, which means the mapping of urban planning, such as building construction and agriculture, which may include crop health analysis, precision agriculture, compliance mapping, yield estimation, as long as wet rice cultivation and crop acreage. And it is also used in natural resource management, such as the habitat analysis, environmental assessment, pest disease outbreaks, impervious surface mapping, lake monitoring, hydrology, land use, land cover monitoring, mineral province, geomorphology, and geology. And it is also used in national security for targeting disaster mapping and monitoring, domain assessment, weapons monitoring, homeland security, navigation, and producing government policy. And coming next to remote sensing, we have the GIS. Remote sensing and GIS comes hand in hand because GIS, Geographic Information System, relies on remote sensing to produce and acquire data. The main step involved in GIS is the work process, information gathering, hardware and software, and the people or the experts that are using the geographical information system. The importance of remote sensing for GIS is that map is the basic element for GIS as a database. Remote sensing is one of the easiest way to make a map. So remote sensing is on the start line of GIS. Producing exact data is very important. So coming to this GIS, we have two main software which we use for interpreting this GIS, which are mainly the ArcGIS, which is not an open source. You have to buy it. And the other one is a QGIS, which is an open source system, which is accessible to anyone. So you can also try on your own. It is constantly being developed and upgraded because anyone can upload a data or a code, an extension. So this is the usefulness of remote sensing for making database. For GIS, observing a large scale of area at the same time, tracing change of land using continuously recording data, and monitoring use of land is needed. And then updating information is easy and saving time and money. So these are all the platforms that GIS has given us. Because rather than going to the place and mapping manually, we can do in the comfort of our office or through a computer, where we can easily make this database. And here is the basic elements of a GIS. A GIS is a 5-part system which consists of people, data, hardware, software, procedures. And the sixth function of a GIS is to capture data, from, which is mainly the satellite data or drone data. And the second function is to store data in a GIS database, which is a GIS database is a georeference database in which all the imagery have a georeference location, which means they represent an actual location on the Earth. And the third one is the query data. And the fourth is the analyzed data, in which analysis is done based on the image acquisition and their location on the Earth. And the next one is the display data. When after all the analysis is done, we produce a map which display all the information which we needed, which may be several layers of map, including a road map, overlain by a land use map. So we will produce this as example. Example here is a geographical information system. Here you can see a thematic layer stacks above each other. In the GIS system, we are able to overlay several thematic layers above each other and combine, which make it easy to and provide several information on a single map. Here you can see the left one is a picture of the ArcGIS in which analysis is done. And ArcGIS is not a free platform, so you have to buy. But QGIS is an open source platform, so you can access this everywhere. You can download it yourself, and you can also try. The features are the same, but the process may be a little different. But once you get used to it, there is no hard process. In GIS, there is also the raster and vector type. Raster data are grid cells with gradual changing data, such as elevation, temperature, or an aerial photograph. Also, they are also known as non-discrete or surface data. Raster data represents a photograph mainly. And this can be raster data is usually continuous or thematic raster, which means in a continuous raster, you will see a gradual change in color or pixelation, whereas in thematic raster, you will see a constant or abrupt change in the themes, which is usually used for expanding or for delineating boundaries. And next, we come to the vector data. While a raster represents a photograph or image, a vector represents a point, polygon, or line, which is shown in a GIS environment. For example, if there is a well or tower in a photograph, in a GIS environment, you may represent that well or tower with a point. And while a road is shown in a photograph, you may represent that road in a GIS environment by drawing a line. And if you see a pond or build-up or building or structure, you may draw that structure using a polygon in GIS environment. Here, this is the example. Here you can see tree is taken as points, and building is taken as a white polygon, and road is taken as this red polygon, and the water is taken as this blue line. So, depending on your needs for various theme, you cannot just basically say, I want to use this Landsat satellite for doing my agriculture work. You have to select exact bands. For example, in agriculture, we have to select band 6, 5, and 2. So this is the band composition for Landsat 8. Landsat 8 has 7 bands, out of which you have to select exact bands depending on your needs. So if you have a team based on geology, you may not select Landsat 8, you may need Landsat 7. So you need to have some information before you select satellite imagery. So as I have said, for agriculture, you may select band 6, 5, and 2. And for calculating the normalized difference vegetation index, there is a specific calculation again. So depending on your needs, you have to select the band, and you also have to do some queries and analysis on the GIS to produce the exact result. And here you can see this black and white image, which may appear as black and white. This is not merely black and white image. This is the digital elevation map, which is produced from the Cartosat series of satellite. This digital elevation map contains all the elevation data you need for producing slope, location, contours, and aspect. DEM are a common way of representing elevation where every grid cell is given an elevation data. This allows for very rapid processing and support a wide array of analysis. Using this DEM or digital elevation map, we are able to produce this. The first one is the aspect map. This aspect map shows the exposure of the different rock faces and the direction in which they are facing. Here you can see the west, the blue one are facing the west, the western side, are oriented along the western side, and these faces are color coded. And on the right side, you can see that the generation of contour from that digital elevation map, which is done. This is done in a GIS environment. here digital elevation model for this as contour. We can check the in contour interval as 10 meter or 5 meter depending on our needs. Here in the map production, we usually put this scale 1:2, and here it is 1,18,000, which means that 1 centimeter on this map represents 1,18,000 centimeter on the actual ground. And here is the slope map, which is produced from the digital elevation model. Here you can see the different angle of slope are also produced. This is all done through the digital elevation model. Here, even the degree up to the point is given. So in Mizoram, the slope is usually around 30 to, especially some steep cases, it exceeds 45 degrees. And here we will show some of the work which we have completed using remote sensing and GIS software. The first one, you can see the water basin maps of Mizoram, which we have completed using the list 4 series of cartoset. Here we are able to degrade the water basin map of Mizoram, and from the water basin map of Mizoram, we are able to delineate the water set map and the micro water set map of Mizoram, which includes all the drainage system and the river system, which we are able to delineate from the satellite data. Here, all the studies we have done, all the guidelines are given by National Remote Sensing Center. We do not make the guideline up ourselves, so we have to follow a strict guidelines for delineating these works. And next here we have the wetland mapping, which identifies the lakes, ponds, and several water bodies using several bands of the satellite imagery. Here we use specific bands which highlighted the water bodies more. And here you can see the water, the lake picture, which is highlighted in the first composite color composition more clearly than the normal color map. And so on. Here, depending on your need, you have to adjust the bands of satellite you have to choose. And here we have the different land use classes, which we have delineated from the satellite image also. Here, the land use classes are delineated as abandoned zoom, agriculture, bamboos, current zoom. All these are delineated through satellite data, and further ground verification is done to verify whether it is really there and to mark the boundaries in which this habitation occurs. In the next slide, we have shown the land use and land cover map of the whole of Mizoram, and we also saw this block boundary, which represents all the district in Mizoram. And next to that, we have the soil map, which is done using a different combination again, different satellites, and the groundwater, which we use the specific bands also, which highlight the water bodies. For all of this, we use different band combination of satellite. So with the advancement in this satellite, we are also able to determine and analyze in more detail the different kind of thematics we want. And here you can see the soil maps. And also we have done the landslide hazard zonation map of Aizawl based on here we use a foreign satellite known as QuickBus satellite, because it produces a very more detailed imagery. From here, along with the combination of the geological map and the various other statistics, such as slope morphology, geomorphology, and the geology, we are able to come up with this landslide hazard zonation map of Mizoram, which is very useful in this nowadays. Aizawl is facing a lot of landslide, and this will also serve as a base in this new rule called the slope development and slope modification plan in Mizoram. It is proposed that they will use this landslide hazard zonation map to base their geological map from now on. And from this is the landslide inventory map, which is prepared by a landslide modeling application, which is developed by NRSC using AI and machine learning tools. From that tool, we are able to delineate all the landslide points in Mizoram, which are later field verified, and all the attributes are given, including the size of the landslide, location of the landslide, whether it occurs within the last year or whether it is an old landslide. So we are able, from field work, we are able to work out. It also detects some false cases, but from ground truth, we are able to identify which one are true landslide. And from here, from this, using this method, we are able to determine that the largest landslide was around 20,690 square meter, and it is still active, and the location is in Aizawl, toposit number 84A09. And the main triggering factor was the year 2023. Here we use the resource set 2 LIS4 satellite in compilation with 10 meter map-tailor digital elevation model, along with the SysDP land use land cover map of 10,000 scale. And lastly, we have come to this LiDAR, which is light detection and ranging, which is an active source of remote sensing, which uses light in the form of short pulse wave instead of a radio wave to detect or measure ranges or variable distance to the Earth. Light detection and ranging is a technology similar to radar, using laser instead of radio waves. LiDAR principle is that it emits a laser pulse on the surface, catches the reflected laser back to the LiDAR pulse source with sensor. And in LiDAR there are a few categories, which are aerial, which include topographic, which is further divided into fixed wings and rotary wings, and the other one is bathymetric, which is used to calculate the depth of the ocean or to find objects within the ocean floor. And the other one is the terrestrial, which may be mobile or static. Here we see the fixed wing type of LiDAR, and here is the rotary kind of LiDAR. A rotary wing may include a drone, which we have will showcase. In the fixed wing, a typical application is wide area mapping, floodplains, forestry application, landfills, quarries, volume analysis, and most 1 meter and 2 meter control interval projects. And the SWOT is also higher, which is 200 meter to 1 kilometer and higher, and it focuses on covering more ground more quickly. And here is the difference between a fixed and rotary LiDAR. A fixed LiDAR, which may be fixed on a plane, covers more ground quickly, but it fires the pulse wave more irregularly or more or less dense. So it is used for large-scale mapping. But the drone LiDAR, it is used for small-scale mapping because it fires the pulse wave more quickly and is more dense. It does not cover usually a large area. And here is the working of a LiDAR with the RTK drone. Here you can see that the drone is fixed with the RTK, which is a form of GPS, which is known as real-time kinematics. And the RTK drone usually have a base station or RTK base station, which sends correction to the drone with the RTK and adjust the satellite correction and send the data to the RTK drone, and it adjusts on the fly. So the accuracy will be more. The accuracy of the drone RTK will be down to 3 to 4 centimeters. Usually using one GPS, it will come down to in terms of meters. But if you use this RTK drone, it will come down to meter or centimeters. Here is the basic principles of the LiDAR technology. LiDAR technology uses laser ranging, which is a system that uses short pulse laser and accurate timing equipment to measure the round-trip flight between a ground system and a satellite equipped with retroreflectors. And GPS, which is a space-based satellite navigation system that provides location and time information. And the third one is the IMU, which is the inertial measurement unit, which provides the orientation of the plane in the sky, which is roll, pitch, and yaw. This may be caused by the atmospheric wind. And this LiDAR produces a point cloud, which is a collection of points or data plotted in 3D space. For example, if you are scanning a building, each virtual point would represent a real point. So the denser the points, the more detailed the representation. And here is the basic of the LiDAR. If you fire a single pulse, it will take 4 or 5 returns. The first return will be the highest elevation, and it will produce from one single fire of the pulse, it will produce about 4 return. So it measures the distance between the return, which gives the elevation data. And here is the process of processing the LiDAR data. Here you can see this is the process in which the drone have a fixed flight plan in which it will fly, through which the overlap need to be set within 60 or 70%. Otherwise, the GPS correlation will be less and imagery will be missing. And so here you can see the right on this side, you will see the base of the mountain. That is not a photograph, but actually a collection of laser points. Those are not photograph. These are 3D points, which represent elevation data. And here we can see we incorporate the drone RTK with this DGPS, which allow us to give more control points. So with incorporating this drone data with this DGPS, we are able to come down to accuracy of 0.09 to 15 centimeter, which is an improvement over the RTK. So GPS is a traditional global positioning system, whereas DGPS is a differential global positioning system. Here you can see the survey which we have done on Dungklang Oil site using LiDAR drone system. Using LiDAR, we are able to remove the tree or canopy cover because the laser shoot through this canopy cover and is able to reveal the structure deep within the vegetation. These are important, especially for geologists, because we are used to mapping the structure, especially in landslide-prone areas. We can determine the shape and structure, and if any fault or active fault are there. So it is very important in terms of geologists also. Now we have incorporated LiDAR in the field of geology also, because normal aerial photograph cannot determine whether a structure is stable or not. But through using LiDAR system, we are able to find cracks or crevices which may trigger a landslide. And here we have LiDAR points which we have generated in the new capital area. Here we are able to determine all these building structures, tree covers. So it is useful for giving a 3D map or representation along with all the elevation data. This is very useful for architectural planning also. And lastly, I want to talk about this. If you are interested in this GIS platform, there is a Bhuvan Indian portal which is free of use, but you have to register. In Bhuvan, you are able to download different GIS data based on your needs or themes. So you simply have to register using your email, and you can download all the satellite data and imageries or various themes according to your needs. So with that, I will conclude my presentation. Thank you.
Yeah, sir, please, yes, please. Thank you so much for a very interesting and elaborate presentation. So if you have any comments or any questions, you can just ask him. Anyone? So if there are no questions, let's thank him once again. So moving on to the last part of the program, I request and invite my own colleague, Dr. Arvind Moria, to please propose vote of thanks.
A very good afternoon to everyone. Thank you, Professor Tiwari, for letting me thank the people. Though you have already thanked Pro Vice Chancellor and other people, but this will be going to be more detailed. So it is my pleasure and privilege to be part of this program. And now it is time to thank and acknowledge contribution of those who worked hard to make this event possible. At first, on behalf of the whole fraternity of Mizoram University, I express my sincere thanks to Almighty for making today's event a grand success and blessing us with a beautiful weather compared to last few days. On behalf of Department of Physics, I extend my hearty vote of thanks to our chief guest, Honorable Pro Vice Chancellor Professor Prabhakar Herat sir, so who spared his valuable time, and because of time constraint, he has another commitment in PUC and he had to leave. I also thank our invited speaker, Dr. Lalram Dina, scientist at Mizoram Remote Sensing Application Center, MIRSAC, Department Science and Technology, Government of Mizoram, for a very wonderful and interesting talk. And this presentation I really appreciate because it was very much detailed and it gives information about how space technology can really help at very local level, which probably no other technology can do. So thank you so much, sir. So now I thank statutory authorities of Mizoram University, namely Vice Chancellor, Finance Officer, and Registrar for providing all the necessary administrative and financial support. Next, I express my gratitude to our Dean, School of Physical Sciences, Professor Suman Rai sir, for his continuous support and encouragement to organize this event. Now let me thank Professor R.C. Tiwari sir for chairing the session and also for his valuable suggestions related to various aspects of the program since past few days. And I must mention a deep sense of appreciation to my colleague Dr. Jordan Moya, who worked tirelessly to make this event happen on ground despite all odds against us, including like very bad weather in past few days. So he would be like man of the day for today, so I would say. Next, I thank other colleagues in the physics department for their valuable contribution. So this kind of event, so this cannot happen overnight, so students work hard for many days. So this I witnessed particularly the happenings in the next room of my office where the first semester student, they were making model of Chandrayaan. So it is for exhibit today. So I heartily thank all of them for making this a very special attraction. And I believe the people from MIRSAC also worked hard for their exhibit, which is there. I think this LiDAR drone, so you can see outside, and I am really equally thankful to them as well for arranging and making this for us, for this program. So next, I thank other students, including PhD scholars, for making various arrangements. So I am really short of words for their involvement and their willingness to take on the completion of tasks beyond their comfort zones. At last but not the least, a big thank you to each of you present here. And this has made this day of National Space Day more special and more meaningful. So have a great day ahead. Thank you so much.
Thank you so much, Dr. Arvind Moria, for thanking everyone in a detailed and elaborate manner. Now we are coming to the end of the program. So before we wind up this today's program, of course, next and the last will be the exhibition, which is there down there. And before that, I request our students to please play the national anthem, for which kindly rise up.
अधिनायक जय है भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे